Hi, good morning. In this video, I would like to simulate the working principle of LDR. You well known about what is mean by LDR. LDR is light dependent resistance. So when light fall on the LDR, its resistance is going to reduced. When light intensity is increased, its resistance is decreased, means the LDR having the negative temperature coefficient. Okay, so LDR will act as the sensor or maybe the transducer which converts light energy into the electrical energy. Why? Because the depends upon the light intensity, resistance will change. Alternatively, it can possible to control the current flowing in the circuit. So the LDR, we can use LDR as the transducer or maybe sensor in the application circuit. So how it works, I will demonstrate. So that I will take one cell or battery in order to provide the biasing. So some operating voltage we have to provide to the LDR. For that I take a DC voltage. In order to provide DC voltage, I connect one cell here. Then I want to measure the current flowing through LDR, so that I need one ammeter. I connect the ammeter in the series circuit, series connection. So the ammeter is serially connected with LDR and battery. So I want to measure the voltage across the LDR, so that I connect one DC voltmeter parallel with the LDR. DC voltmeter connected parallel with the LDR. So one common ground required. So the common ground is connected to the circuit. So see, this is the LDR symbol. Near with the LDR, some display is there. This display we can adjust the intensity of the light which fall on the LDR. We can increase like this. The intensity is increased. You can see now the intensity is 5, like that. Little bit also I can zoom. Then you can view very clearly. You can see visible. See, we can decrease the intensity using these two arrow. Okay, so this arrangement used to change the resistance in the LDR. Maybe the display is light intensity. If you are increasing the light intensity, the resistance of the LDR decreases. So accordingly, the current will increase. So simply, if the light intensity is more, the current is more. If the light intensity is less, the current will be less. Okay. So maybe this LDR having the negative temperature coefficient. Just before simulate this one, I can adjust the battery voltage. So any voltage you can set. For my convenient, I will set 12 volt. You can set any volt. And also the LDR will provide milliamps current only, so that I want to adjust this meter property into amps to milliamps. Okay, you can set microamps also, nothing wrong, but definitely the LDR will produce current in milliamps only, so that we have to set milliamps. So now we can run this circuit. Say now the voltage is 12 volt. The voltage across, just we have to pause the simulation. So the voltage across the LDR is 12 volt. The battery also 12 volt. The reason is the battery and LDR connected in parallel, so that in parallel the voltage will be same, so that the voltage across the LDR is 12 volt. Now the current flowing through the LDR is 0.25. The intensity is 3.1, so that the 0.25 milliamps will flow through the LDR circuit. Suppose I am reducing, the intensity is very low. Now the intensity is 0.1 I set. Okay, now let me see what is the current flowing through this LDR now. See, now the current flow in this LDR is 0.01 milliamps. If the intensity is low, current flowing through LDR also low. Now the current is 0.01 milliamps. Once again, I am increasing this intensity is little more. I will make some 8 or 9 or 10. 10.1. Now the intensity is 10.1. Definitely the milliamps should be more than 0.01 milliamps. Okay, the current should be more than 0.01 milliamps. Now the intensity is 10. Okay, let's see what happens. See, now the current is 0.69 milliamps. Okay, if the intensity is more, the current also more. So this is the function of LDR. So we can use this LDR in various applications. For a simple application, for automatic street light, we can use the LDR. When night time, the light is dark, so the LDR resistance is more, the current flowing through the circuit is less. Daytime, the light intensity is more, then the LDR resistance is very less, the current flowing this LDR is more. Okay, so this LDR we can use in the automatic street light projects. That project I will show you in the next video. Okay, so I hope that this explanation will helpful for the beginners, those who are studying first year diploma, second year diploma, or maybe first year BE students, second year BE students. This explanation I hope that will helps a lot. So I request you like this video, share to your friends. Don't forget subscribe our channel. Ask your friends to subscribe the channel. Thanks for watching.